All right, today we're looking at Unit 2.4. Today we're going to look at solving systems of equations using graphing. So today we're going to solve systems of equations by identifying the intersection of the graphs. So here's what you first need to know is that systems of equations in two variables are systems where there's two equations or more, a set of two equations or more with the same variables. They do have to have the same variables. You can't have like an x and a y and an a and a b. They have to be the same two variables. With a system of two variables, there are three possible outcomes. The first is that we could have one solution, and that is whenever there are two lines that intersect at one point. And the equations for that situation are going to have different slopes. So anytime we have different slopes, we will have one intersection. Every time we have different slopes between two lines, between two equations, we will have one intersection point. Next, we have a case where there are zero solutions, no solutions. And those are parallel lines. And of course, we know from geometry class that parallel lines have congruent slopes. So we have the same slope. So the same slope, but we have different y-intercepts. So anytime we have a different y-intercept but the same slope, we know we're going to have parallel lines. Now the third case is that there's an infinite amount of solutions. All right, so we graph our two equations and we come up with the same slope and the same y-intercept. Then of course those two equations graph to the same line, and therefore there are an infinite amount of solutions. So same slope, same y-intercept. All right, so we're going to solve these things by graphing. First we have y equals negative 3x plus 2. 2 is our y-intercept, so we start with a y-intercept of 2. Negative 3 is the slope, so we go down 3 and to the right 1. Down 3 to the right 1, all the way across. Up 3 to the left 1, all the way across, and then we are going to just connect the dots. Looks like that. Then y equals 2x minus 3. Y-intercept of negative 3 is slope of positive 2. Means we're going to look like that. And again, we can just connect the dots. All right, there are the two graphs of those equations. We do have an intersection point, and our intersection point is at 1, negative 1, where those two lines intersect. Okay, to graph 5x minus y equals 3, I'm going to have to do a little bit of figuring first. I got to solve this equation, get y by itself. So 5x minus y equals 3. I need to get y by itself, so the first thing I'm going to do is subtract a 5x from both sides. And then that gives me negative y equals negative 5x plus 3. I don't want negative y though, I need y by itself, so I got to divide by negative 1. So just negative 5 divided by negative 1 is positive 5x. 3 divided by negative 1 is negative 3, so I end up with y equals 5x minus 3. And then the second equation, negative x plus y, if I add an x to both sides, I get y equals x plus 5. So now I can graph this. The first equation, y equals 5x minus 3. I have a y-intercept there of negative 3. A slope of 5 means I go up 5 to the right 1. I can also go down 5 to the left 1, and then just connect the dots. And then x plus 5 means I have a y-intercept of 5 and a slope of 1. So the line is going to look like that. and just continues on like that. All right, so our intersection point is right there at 2, 7. All right. So we'll do the same thing here for example 3. We got to solve to get y by itself. So 7x plus 2y equals 16. I'm going to subtract 7x from both sides first to get negative 7x over on the right side. And then I'm going to divide by 2. Y equals negative 7 halves x plus 8. And then on the second equation, I'm going to add 21x to both sides. Oh, that's what should be a y. So 21x plus 24, and then divide by negative 6. 21, I can't divide by negative 6 equally, but I can simplify that. Both of those are divisible by 3. So that simplifies to 7 over 2. And there's going to be negative because this negative 6 was there. So it's negative 7 halves x, and then 24 divided by negative 6 is negative 4. So negative 7 halves x minus 4. So now plotting these, y-intercept of 8, right there. Slope of negative 7 halves means I go down 7 and to the right 2. 1, 2, 3, 4, 5, 6, 7 to the right 2. So it looks something like this. All right, and then the second equation, negative 7 halves x minus 4, y-intercept of negative 4. Slope of negative 7 halves. Can't really go down 7 because there's only 6 spaces left on my graph below that point, so I got to go up 7 and to the left 2. So I can go like this. But that is good enough for me to see that these are parallel lines. Also, notice I have the same slope, so those are obviously parallel lines. Since I have the same slope, parallel lines are congruent. These lines are never, or not, parallel lines are not congruent. Parallel lines have congruent slopes, and because they have congruent slopes, these are never going to touch, so there are no solutions. All right, so the situation here, determine the number of solutions for the following: 1, none, or infinite. The slopes here are the same, so 6x and 6x, so the slopes are 6 on both of these, but they have different y-intercepts. Slopes the same, different y-intercepts. That means we have no solutions. No solutions. Just looking at the graph here, I've got 2 lines that intersect at this point. So there is one solution to that system. And then C, we've got to get y by itself for each of these. So 2x minus y equals 4. We've got to get y by itself so that we can see what the slope and y-intercept are. So we can subtract 2x off of both sides. What, negative y equals negative 2x plus 4. Divide both sides by negative 1. Get 2x minus 4. And then we got 6x minus 3y equals 12. And we can subtract 6x from both sides. And then divide by negative 3. Negative 6 divided by negative 3 is positive 2x. 12 divided by negative 3 is negative 4. Notice we have the same y-intercept and the same slope. So that means we have the same line. And that means we have an infinite amount of solutions. All right, the last question really isn't going to work for what we're doing here today, so you can probably solve that one on your own, but if you do want to see how it's worked out, just come see me in class or send me a message and I might be able to help you out. All right, talk to you later. Have a great day.